Hey guys, this is Mr. Quintanilla and we will be continuing our topics in physics. We will now begin discussing vectors and two-dimensional motion. So, let us get started. So, vectors and 2D motion. So, a review of vectors, because we have already discussed vectors in class. Physical quantities in physics can be divided into two categories, scalar and vector quantities. A scalar quantity has magnitude but no direction. So it shows you a number, but it doesn't specify a specific direction. So for example, you have temperature, time, speed, and volume. For example, the temperature could be 40 degrees. It shows you a number, but it doesn't show you what direction. The time, what specifies what time it is. For example, it's 12 p.m. It shows you a number, but no direction. Speed, it tells you how fast you're going, and volume, it tells you a specific or the number amount of liquid in a container. A vector, on the other hand, has both direction and magnitude. So not only do you have a number, but now you have a specific direction, whether north, south, east, west, northeast, northwest, etc. So now you have a certain direction. So for example, you have displacement, velocity, and acceleration. All these we have already discussed in class. So you know that they have a specific number and a specific direction, and all these are considered vectors. Now there are many more other vectors that we will consider as we move on in physics. For example, you have force, you have momentum, that are also vectors because they specify a number and a direction. But we will discuss this as we move along through physics. Now, in order to understand the vectors and two-dimensional motion, we must first discuss the resultant vector. So, just a little reminder, when you're adding vectors, you must make sure that they have the same units and must have similar quantities. So, same units meaning you when you're adding two vectors, they must have the same unit, whether meters, or or kilometer. You cannot add a vector that has kilometer and a vector that is in meters. You would have to convert one or the other. Similar quantity, meaning that you must be talking about velocity for both vectors. You cannot add one vector for velocity and another vector for displacement. So that is what it means, same unit and similar quantity. So let me erase this so you guys can see what, I hope it works. Let me get my eraser. Okay. So when you add two vectors together, it yields the resultant vector. So you can see here in the diagram, you have vector A and vector B. When you add them together, you form vector R, which is the resultant vector. So we will do a lot of practice in how to draw the resultant vector in class. But just for you to get the idea, you add vector A, vector B, and vector R is your resultant vector. Now some properties of vectors. Vectors can be added in any direction. So if you have a vector going to the north, vector to the south, you'll be able to add them together. If you have a vector going to the north, then to the northeast, then to the south, all of these will be able to add them. So that's a good property of vectors. Now, let's take for example, we have vector 1 that's going to the north and vector 2 going to the right. So how do I draw my resultant vector? We always begin where we began. So we started in vector 1 towards the bottom because that's the arrow is going that way to the north. So we began in this red spot. So you would draw your resultant vector with the arrow pointing towards the beginning of towards the end of vector 2, right there. So your resultant vector would be as follows. Now, you can see that this forms a right triangle, and we will discuss how right triangles have a special rule when it comes to finding the angle and finding the values of the leg of A, B, and C. Now, what happens if you have a weird shape like this? For example, an object goes to the northeast, then to the north, then to the northeast again, then to the southeast. So, how do you draw the resultant vector? Once again, you begin where we started, and you draw the vector to where you ended, which is right here. So your resultant vector will be as follows. So we will now do some examples of some quantities that of which could be scalars or vectors. So for example, the first one, the acceleration of a plane as it takes off. So the acceleration, you know by now that acceleration is a vector. It shows you a number and it shows you direction. So this would be a vector quantity. How about the number of passengers on the plane? It gives you a number, the number of passengers, but does it specify a direction? North, south, east, west? No. So this would be a scalar quantity. How about the duration of the flight? How long does the flight last? Does it show you direction? No. So this would be a scalar quantity. The displacement of the flight. Now you want to know the distance of the plane over a period of time. Would this be a vector or a scalar? A vector, because it shows you a number, a magnitude, and a direction. How about the amount of fuel for the flight? It shows you the amount of fuel, the number, the magnitude, but does it specify a direction? No. So this would be a scalar quantity. So make sure you get a lot of practice in knowing the difference between a scalar and a vector quantity, because in the test you will have some examples and you will figure out which ones are scalars and which ones are vectors. Now, vector operations. How do we find the resultant vector, the magnitude, and the direction? Well, we know that Pythagorean theorem, a squared plus b squared equals c squared. So looks very familiar. You have taken geometry and pre-calculus. A is one of the legs of the triangle, B is the other leg, and C is the hypotenuse. So you take the Pythagorean theorem to find whatever value you're looking for. Now, in physics, you can also apply them to the x and y direction. So, in this triangle, you see x, or the displacement in the x direction, the displacement in the y direction, and then d for distance. So it's very similar, except that the letters change, but the concept is the same, x squared plus y squared, and this should be d squared. So we're going to use a lot of Pythagorean theorem, right triangle rules to solve for angles and solve for sine, cosine, and tangent. Now, before finding the direction, how do we find the tangent of a right triangle? You can see here a right triangle, so you want to find the tangent. So, in geometry, you have probably heard of SOHCAHTOA. So SOHCAHTOA, sine, cosine, and tangent will be your best friends for this chapter. So how do you find the tangent of an angle? Well, to find the tangent, you take the opposite side over the adjacent. So opposite divided by adjacent. As you can see here, opposite by adjacent. and that will give you the tangent of the angle. But what if I want to find the angle? What if I have a right triangle? I have a value, x, I have the hypotenuse, h, but I want to find the angle. What is my angle? Is it 20 degrees, 30 degrees, 40 degrees? So how do we find the angle? Well, we have a formula to help us out to solve for the tangent, for the angle, I'm sorry. So you take the inverse tangent or the opposite of tangent, so tangent inverse, and once again opposite over adjacent. And we will do more examples of this in class to help you guys get comfortable in finding the angles. Now, in two-dimensional motion, we're going to split the vector into its components. So let's say you have an object, let's say a football, and excuse my ugly handwriting for a football, but let's say I have a football that is kicked at a certain angle, let's say 20 degrees. So that is your, and it's the velocity is 10 meters per second. So that is how fast the ball is going. So that is your vector. Now, we want to split it into its components. So how are we going to do that? Well, we know it's going to the northeast. So we're going to split into the y and the x. So you're going to have a y component and an x component. So that is where we're going to use sine and cosine, because you form a right triangle. So you're going to use sine to find, you're going to use sine and cosine to split the velocity into the x and y components. So to find sine, you take opposite over the hypotenuse. So you want to find the sine of this angle that I just shaded in blue. You take the opposite over the hypotenuse. You want to take the cosine, you take the adjacent over the hypotenuse. So just remember these formulas, and we will do more examples in class in solving for sine and cosine. Now, what happens when you add vectors but they are not perpendicular? They are not right triangles. So what if you don't have a right triangle? This is not a right triangle, so what if you don't have that? Well, what we have to do is actually draw. We need to draw a line that helps us make a right triangle. So now we drew the line, now we have an angle, and we have a right triangle. So now we're able to solve whatever value we're looking for. So this is where you have to use your imagination and your critical thinking in figuring out how to draw that line. Now, projectile motion. So let us now begin projectile motion. So let's say you have an object that is kicked and it lands on the other side a certain amount of distance. So it was kicked at an initial velocity of 5 meters per second. So we're splitting the velocity into the y and x component would help us a lot in solving these problems, because you will find out that throughout the pathway of the object, the y direction is always changing, but the x is always the same. It never changes. So we're going to figure out the properties of projectile motion. So you can see here in the diagram, I got a little ahead of myself with the diagram, but you see here in the diagram, you have the velocity, you have the angle. So we're going to split into the vector into its component, the y and the x. And you will see that throughout the pathway, the component will be changing. The y component will be changing, and the x will be remaining the same. So what is projectile motion? Projectile motion is the motion that an object exhibits when thrown, launched, or otherwise projected near the surface of the earth. So basically, um, how a object is launched or travels through the air. That's what a projectile is. Now, the pathway of a projectile is parabolic. It's a parabola. So on other problems you will see, you will assume that the object travels in a parabola. And the horizontal velocity, the x direction, is always the same. So the horizontal velocity, very important. Horizontal velocity is constant. It is not changing. Now, we have probably seen these equations already, very similar to what we've been talking about. So just keep these equations in mind. We will do a lot of practice with these equations. But these equations will help us figure out how objects are falling from a cliff. For example, we have a cliff here, and the object falls in a parabola form to the ground. So these equations right here will help us figure out the velocity, the distance that it travels, and the time. So how about the horizontal motion of a projectile? So let me go back. Okay. So like I mentioned before, you know that in a projectile, the vertical velocity is changing until you get to the maximum height, to the highest point, in where the y direction equals 0. So you only have the x. So all throughout the pathway, the x direction doesn't change. It stays the same. So that is one of the important properties of projectile motion, is that the x direction is constant. It is not changing. And knowing that fact, you can actually figure out the distance the object travels. By taking the displacement, you take the velocity of the object times the time, and you should be able to figure out how far the object traveled. So you can see here in this diagram, if you were to drop an object onto the ground and then swing an object in a parabola form, they will both land at the same time. But look at the parabola. The horizontal motion is the same. It is not changing. So your Vx is not changing. It's constant. It's staying the same. But look at the y. It starts off small, then it gets bigger and bigger and bigger. So your velocity in the y direction is increasing. So this is a very important property of two-dimensional motion, and it's very important that you memorize the difference. Now, how about projectiles that are launched at an angle? So, in physics, we launch objects, or we kick objects at a specific angle. So we want to know the angle of that object. So that's why here in these equations, which are the kinematic equations, you have cosine, cosine, sine, sine, and sine. to take into account the angle. We will do some examples of this, but these do get a little complicated and a little tricky. So, although it might not be on the test, um, I do want to go over some examples with you that we can see how angle plays a role in how far the object travels and how high the object goes. And we will do a lab that will show how the angle plays an important role. And you can see here in this diagram that the same thing, as the object is kicked, it goes through the air. Look at what's happening to the y direction. It's decreasing. It decreases until you get to the highest point. The highest point, which is the maximum height. At this point, your y is 0, but look at your x. The x stays the same. It does not change. So Vx is constant. Vy is changing. So this is the basics of projectile motion and vectors. Vectors are a major role in two-dimensional motion. So see here, all these are vectors. So we're going to be doing a lot of examples of this in class. So I just gave you guys in the nutshell of what vectors are in two-dimensional motion. And in class, I'll give you more visual representations and examples to solve. But I'm going to show you guys a video of projectile motion.
Objects that are thrown or launched into the air are called projectiles. If their motion is influenced only by Earth's gravitational field, they trace out a graceful arcing path called a parabola. A toy stomp rocket is launched into the air. Click the points along the rocket's path to learn more. A projectile's initial velocity may be broken into vertical and horizontal vector components. The launch angle is related to these components. If the only force acting on a projectile is Earth's gravity, the projectile accelerates downward at 9.81 meters per second squared. As a result, the magnitude of the vertical velocity component decreases as the projectile ascends. At the peak of the projectile's path, the vertical component of the projectile's velocity is 0. Notice that the horizontal velocity component stays the same as it was when the object was launched, if frictional forces such as wind or air resistance can be ignored. The horizontal velocity is not affected by gravity, and therefore, the acceleration in the horizontal direction is 0. When the projectile begins its descent, the magnitude of the vertical component of its velocity begins to increase in a downward direction. Click the feature to explore how a projectile's initial velocity affects its flight path.
Okay, class. So we will go over all this in detail in class. So please make sure you fill out your PowerPoint worksheet and be prepared to solve problems in vectors and two-dimensional motion. Thank you and have a great weekend.